All right, in this video, we're going to look at rationalizing the denominator. So basically, we don't leave an irrational number on the denominator. So a third is what we call an irrational number. Okay, it means that you have infinite decimal places if you were to evaluate it. So we call the square root of 2 the exact value. But if we were to take the actual square root of that, we would get, I think, 1.4 something, and the decimal places go on forever. So we call that actually an irrational number, irrational. Can't spell, but it's an irrational number. Whereas 2 is a rational number, or a half is a rational number. So what it means by rationalizing is we just want a whole number on the bottom, on the denominator. We can't leave it as a third. Now to do that, and some of you have already practiced it, and I've actually taught you in a previous video, but we take whatever is on the denominator, whatever third's on the denominator, and we multiply it by that third. And we put that third on the numerator and the denominator because effectively this is just 1. So we're not changing anything, we're multiplying it by 1. There's just 1 that looks a bit different. Now, when we go back to fractions, remember you multiply your numerators. So 1 times the square root of 2 is 2. And then on the bottom, we have root 2 times root 2. So I might just put here 1 times 2. Now, square root of 2 times the square root of 2 is the square root of 4. And that square root of 4 is 2. So the whole point of doing this is you can see we now have on our denominator a rational number. So this 1 over root 2 is the same as square root of 2 on 2. It's exactly the same. Okay, let's try something else. Let's do D, which is 4 on root 5. So we multiply it by whatever we have on the bottom, whatever third's on the bottom. So in this case, it's square root of 5. So on the top, we have 4 root 5. And hopefully by now, you know when you multiply the same third, you're just left with the number. Okay, so the root signs cancel out, and you're just left with the number 5. All right, let's move on now. Let's scroll down to question 2. So question 2, it says rewrite, basically separate your square root sign. So the square root of 2 on 3 becomes the square root of 2 on the square root of 3. And we need to get rid of that third on the bottom, so we multiply by the square root of 3, like so. When you're multiplying thirds, you multiply the number inside, so 2 times 3 is 6. And then on the bottom, we are just left with 3. Now remember, this is not the square root, so you can't cancel this 6 and this 3. Okay, it just stays as the square root of 6 on 3. Let's do maybe question G. So this time we have the square root of 10 over the square root of 3. So 10 times 3 is 30. And then we have 3 times 3. Oh, sorry, root 3 times root 3 is just 3. And sometimes this number can be cancelled, but 30 can't be cancelled. There's no perfect square that goes into 30. All right, let's move on. I think there's another question down. Yep. So I think there's 2 more questions. Okay, so the same thing applies here. Let's just do one of these. Let's do F. We'll do the very last question. So we've got 2 root 7 yep, on root 15. So we multiply by whatever that third is on the bottom. So on the top we have 7 times 15. And 15 times 15 is just 15. 7 times 15. Gosh, what is that? So I'm going to cheat and use my calculator. 105 to 105 over 15. I'm not too sure whether 105 can be simplified. I know 25 doesn't go into it. Let's try. It's 9, no. 4 doesn't. 9 doesn't. 16 wouldn't. 25 doesn't. 49, 36. No, I think 105 is as simplified as it will be. You know, I can always just check. Let's just cheat and, well, not cheat, 3F. 3, 3, 3, yeah. Okay, so it can't be simplified. Even though it's a high number. What question were we doing? Oh no, it's still in the answers. Okay, there we go. We're doing question F. All right, let's move on to question 4. So question 4, you now have a number on the bottom as well as a set. So let's do A. So you only need to multiply, you can multiply by the 5 root 3, but you only need to multiply by the root 3 because it's the only thing we need to get rid of. If you multiplied by the 5 root 3, you're going to create more work for yourself because you're going to have to end up simplifying it anyway. So here we have 4, then 7 times 3 is 21. And then on the bottom we have 5, and then your root 3 and your root 3 gives you 3. So let's just rewrite that, 21 over 15, and nothing can be simplified, so we just leave it as 4 root 21 over 15. Okay, let's choose maybe G. So we've got 9 root 6 over 2 root 3. Now with this one here, I wouldn't even bother rationalising the denominator. I mean, you can, but you're creating more work for yourself. I see this one. Oops. All right, sorry about that. I've got a visitor at the door. Okay, so we had 9 over, hold on, let's just get the pen back up. So we can rewrite this fraction as 9 over 2 times root 6 on root 3. Okay, so it's exactly the same thing. You can separate your fraction into two parts like that. Now, you should recall when we did division that you can actually do this under the 1 square root sign. So we're now left with 9 on 2 times the square root of 6 divided by 3, which is 2. And then let's bring everything together. We get 9 root 2 over 2, which is exactly what you would get if you rationalise the denominator. So we're going to rationalise the denominator as well. I'm just going to remember which question I was doing so I can write down G. Okay. So 9 root 6 over 2 root 3. So this time we're doing the same question. We're just going to do it by rationalising the denominator. So we're going to have 9 and 18, and then 2 times 3. Don't accidentally square these. Don't go 3 times 3 is 9. The square root basically just leaves it as a 3, not as a 9, because it's the square root of 9, which is 3. I hope you got that. Okay, so 18 is 9 times 2. And then on the bottom we have 6. And then we get that 9, which is 3. So 3 times 9 is 27. And 6. And then we've got a common denominator, a common factor, sorry. So 3 goes into 27 9 times and into 6 twice. Okay, so we still get the same answer. We just do it one by simplifying the fraction part first, and the other one was by rationalizing the denominator and then simplifying. So I think it's actually easier, like when we did division, to actually deal with the any simplifying first before you rationalize the denominator or before you actually simplify any surds. Okay, I'm going to stop there, keep it under 10 minutes. Good.